Hello, I wanted to spend a little time today going through an example of prediction, and in this case, it relates to in the AI space potentially to things like prognosis, right? So, if you think about what a prognosis is, it's essentially a prediction of longevity. Um, we don't usually like to talk about it a whole lot, right? Because nobody wants a bad prognosis, and most of us don't want to talk about our eventual demise. So, sorry for the start on the wrong screen, but so on the Kagle website, there's a life expectancy data set that has just that. It's essentially a life expectancy considering some various variables, and those include things like income, and so on. The fact is, our life expectancy is often tainted by such things as how well we take care of ourselves, how much food we get, and so on. Whenever you take a look at a life expectancy data set like this, the first time you look at any data set, you'll want to get a sense of what it's about. What is it, right? So you typically kind of work through how did it come to be, and in this case, it's on Kaggle. It was part of some contest to do prediction, but it's a good data set in that it lets you kind of learn this. And the key questions that this it tries to answer, and I'll blow this up so you can see it, are things like what factors that are initially chosen impact life expectancy, and the what are the predicting variables that actually affect your life expectancy. So the prognosis, if you think about it in a medical sense, is a very narrow set of criteria, right? So if you're predicting a prognosis, it's essentially multiple factors. There's probably you're going to take into things like do they their lifestyle, so smoking, drinking, exercise, and so on, schooling, perhaps, and so on. If you're actually doing that on that subset of individuals that happen to have been diagnosed with a particular condition. This is a very generalized case, but it's still kind of interesting. So what I thought I would do today is, first of all, take a look at this data, and I believe I downloaded it earlier. So let me find it, and here's what it looks like. So I'm going to first of all open it up in the granddaddy of all data investigation tools, Excel, right? So sadly, and it's still used as primarily the main vehicle for most analytics, frankly, because it is pervasive, understandable, simple in many ways, and a lot of times is good enough. So you can see we have various measures. These measures themselves aren't all that useful, right? So alcohol, what is 0.1 and 0.3 and 4 and so on mean? That's where you really have to know your data set. You need to go in. Part of your analysis process is to take a look at the data card, and in particular, what are the columns supposed to be. So zoom out some so you can actually see the whole context, right? So you have the details, and then there's the narrative about the file, but also more importantly for each of those columns. So in this case, we'll pick on alcohol, and if we scroll over, it'll be the alcohol recorded per capita, 15 plus consumption in alcohol in liters of pure alcohol. So that's the description of it. So it gives you a sense of it. This also kind of gives you the distribution, very skewed towards zero, and there's a few out here at 12.6. That's probably really hard for you to see, but if you zoom on in, you can kind of, I want you to see it, the edge case here, and it lets you see that, right? So now that we've got a little bit of a sense of the data itself, I thought we'd go over and take a look at it in my favorite analytics environment, which is Databricks. I'm going to go ahead and going to upload that data. That's the first thing. So if we go take a look in catalogs, and this is a Unity catalog equipped environment. I set this up as part of my Lakehouse Cookbook work whenever I was doing that, and as my obligatory plug. If you want to learn more about Databricks in particular, I wrote this for it to be very accessible. So if you search for Databricks Lakehouse Platform Cookbook and probably some subset of that search string, you'll be able to find it. And it does cover the topics that are of interest to you. If you're wanting to learn about big data analysis, lake houses especially, because it's all about building a lake house. But back to the case at hand, we're going to go ahead and to keep this fairly quick, I'm going to use an existing Metastore, and I'm going to probably stick it down just into Lakehouse Cookbook, and this would actually be most likely at best a bronze item. So I'm going to go and create a table. Let's see if it gives me, yes, it gives me the option here to upload my file, which is what I was hoping for. So I'm going to drop this file on here, and it's going to pull it in, and we're creating a bronze table that is life expectancy. For brevity, I'm not going to go through the whole process of converting it to bronze, silver, gold, which is where you apply business rules to the data. We likely will do a little bit of data cleansing if we need to, but hopefully we won't. So what's going on right now is it's being uploaded and being analyzed. It's going to take a little bit of time, and now we can see the data. And it pulled in, it's got the columns. It was able to figure out that year is a number, that life expectancy is a double, and so on. So it's pretty smart. It knew that it had a header column by just dropping it on there. So you take a look at it, looks pretty good. If you didn't like what it was doing, you could change it. So you could adjust these values, or potentially adjust the data type if you thought it messed it up. In this case, it did a great job. Can set some advanced attributes. For this, we don't care. I'm going to go ahead and see if it'll let me, maybe already running. So it did actually spin up a little cluster out here for me. So one of the things that powers this is these SQL warehouses, and you can kind of see one over here. I'm not going to go into all the details, but that's how the magic really works. Whenever you work in a big data environment, you have a combination of the code that you're trying to use. In this case, Databricks did all of that. You got some data, plus you've got a compute and storage. So the compute piece is this cluster that it spun up for us that I'd previously defined. And me being cheap, it's a very small cluster, part of why it's probably taking a while to go. So now we're going ahead and creating the table. It's going to take a little bit to create. This is taking us from that preview state to the real state. If the file were larger, and this one's a relatively small file, it's only like 326K, it would have taken much longer to pull it in, and likely it would have sampled a subset of the file before attempting to figure out data types and so on. Since it's a little file, went ahead and just probably loaded it all up. It's probably smaller than the sample size, and now we're actually going ahead and we've created it. We can see it now because it is the selected file. It's a little hard to see potentially on the screen, but that is the selected file. And it's showing us the overview to start. In this case, it's essentially the schemas, right? So the schema. So it's got country, year, and so on. You can click on the sample data and see a little bit of a sample of what it looks like. You get some details if you're interested. This is more details in the sense of storage. This is where it's being stored at inside of a particular external storage, it looks like. So this is a Lakehouse Cookbook DFS. So this is an external ADLS Gen 2, Azure Data Lake Storage Gen 2 endpoint, so location. And it automatically created some stuff for us of like, that's a GUID. And then this is the tables, and then another GUID. So it's making sure that there's no collisions, but we do have control over where it's at. Working on across permissions in the Lakehouse, you want to control who can see stuff. For what we're doing doesn't matter. The history, this will let us know what has been done before. There's not really any lineage here because it just entered the environment. If we take that table do something to it and create another table, you're going to start seeing lineage showing up. Some insights, probably not too much yet because it's brand new, but we can over time see who's looking at the table, what they're doing with it, and so on. And then some quality. And for that, we're going to have to turn some stuff on. Not going to do that because it's a bit of a departure. Now we're going to kind of shift gears, right? You've got some data out there. Now we're going to go over here to take a look in the experiments, right? And in this case, we're going to create an AutoML experiment. So AutoML, right? To be clear, whenever you're doing things like prediction and regression and so on, you're in the world of machine learning. It's a subset of artificial intelligence, so you still are doing AI, but it's kind of an older school sort of sense of AI. Looks like I may have to go out and create a cluster that is a ML Databricks 9.1 or newer. So I'm going to go ahead and open this up in a new tab, go over, and I may already have one. I may just have to spin it up. That should work. So let's go ahead and start that up. And so what I'm looking at here is the type of cluster. The runtime is a machine learning runtime. What that means is that Databricks went to the trouble of creating kind of two different, if you will, cookie cutters or recipes or templates, right, for these things that run the compute, these clusters. And it's essentially a virtual machine that is running, and it's, or something is likely moving towards being a containerized thing. It's not here yet. I don't know that I can actually create one of those yet. It's in preview, but probably not for me. I'm not seeing it. Looks, the UI is a little different for it whenever it is allowed, but it's not there yet. So we're basically creating you can create a cluster. You can tell it what machine time or what runtime to use. That's essentially what things in addition to the core operating system stuff you want installed. So it could be that you want some of the popular machine learning algorithms or frameworks like PyTorch or whatever installed. And so whenever you're doing AutoML in particular, it does use machine learning algorithms. In particular, it uses most of them relative to the job at hand. So we'll also need to think about, on a machine learning perspective, what is we're trying to look at. And it's likely going to be, we have to think if this is a regression problem. It's not really, it's more of a prediction or possibly classification. So while that's spinning up, we'll shift back to the configuring it. We'll do have to pick that, but we can likely, we got to do that first. So I'm going to pause the recording. Well, maybe not. Let's see how long this will take. So while it's doing that, let's walk through the process of creating a cluster, just so that we talk about it. So you can't do much out here yet till it's up and running. So to create a cluster, you can go out. You have a policy in the case of Unity Catalog, and in general, you can. In this case, we're going to leave it as unrestricted. It's going to be a single user access mode. That means this is going to be my cluster or a particular user's cluster. You do have potentially non-single user activities that are dependent upon policy and so on. It is going to be a multi-node. We do want the newest and most stable runtime version. So, but we do also want it to be for ML. So we select the ML tab and go down here to a non-GPU enabled runtime for it. What that means is that if you select the hardware that goes with it that has a GPU, and you select the GPU enabled runtimes, all the configuration stuff that you normally might have to do to get the GPU to work is done for you. And if you've done it on your own machines, you know that's a non-trivial amount of work sometimes, especially with certain frameworks. So you can select which one. In this case, I don't particularly want it. You specify a range of workers, or you can also specify a single workload type up here. If you did a single node, you wouldn't have this. I want multiple workers. I'm going to be really cheap and take it down potentially to one. Going to also be cheap and say I want spot instances. Spot instances, they save you money, but they may go away, right? So what Databricks will do for you is if there's compute that's out there that's already been allocated for something, but it's not really being used at the moment for a certain amount of window, I'm sure, it becomes available for you to use. You still have to pay to use it, but you pay less to use it. The thing is, if somebody that actually paid for it wants it back, you get kicked out. So you do want to think about that when you're doing this in the stuff like a research or for your personal exploration. You don't care if you're working on it on a enterprise class problem that is mission critical. You care. So think about that as you're configuring it. You can associate tags with it as well. This might be something like effort, right? What is it for? And we'll say it's for training. And then if you were doing this in a real enterprise thing, you might have a project, right? And this is, and we'll say life expectancy. And what this does is allow and we're in the Azure environment at this point and using Azure Databricks. You can see up here at the top, Microsoft Azure. And so what this does is that part of the Azure platform is the collection of tags associated with cost. So you can figure out what you're spending your money on. This is what enables that. We'll go ahead and look for some additional tags that are automatically created. Databricks, my name, the name of the cluster's ID, which will be assigned after it's created. And then you can get into some advanced topics. This is something that you don't mess with this unless you know what you're doing, right, is what it comes down to. So generally speaking, we don't have to worry. Go ahead and click compute. This is going to spin up a new cluster that has that name and that is this configuration, and that's going to take a bit. So hopefully by now we've got my personal cluster up and running. It's the one that we started before, not the one that we're just creating, right? Because this was named Alan Dennis's cluster versus Alan's personal compute cluster. So different name. This is what you have to figure out when you're doing AutoML is what are we trying to do? Classification, regression, or forecasting. We're going to go with classification for now. Although no, actually, I think probably let's try regression. Then we pick our data set and we put it up here in AdventureWorks, or I'm sorry, in Lakehouse Cookbook, in the bronze layer, if I can click the right thing, and there's life expectancy. So let's go ahead and select that. It's going to take a look at it and figure out what are we trying to predict, and let's say life expectancy. And then you can give it a more meaningful name for what now we care. So you also have out here the ability to do imputation, right? So what AutoML does out of the box, the default behavior is that it will convert null values. It automatically puts in null values in the table. So if there's truly nothing there, it at least sets it to null. But you can also pick some additional ways of doing things, of what do you want to put in it. So to talk about what imputation is, an example of adult mortality, it's going to be people dying as adults versus infant deaths, right? So that's kind of what we're talking about. You could say that you want to replace it with a mean, the median, or the most frequent, or some constant. So sometimes if values are missing, you want to put a 0 in. Other times you want to make sure that the missing of that value doesn't throw off the results, right? This is assuming you want to leave it in the data set. A lot of times whenever you're doing this stuff for real and not just kind of demoing how AutoML works, if you're doing it for real, then you likely will want to do some pre-processing and cleanse the data and make sure that it's what you want it to be, which is what we typically see. So at this point, let's go ahead and kick off AutoML. So this is going to go out and start doing some work for us. This is leveraging a tool called MLflow. And Databricks created it, or initially created it. It is an open source effort, and it is a very cool effort. So it looks like we did some uh, move some stuff around for us. So they tell us where it is inside of the path, and so it's underneath of the users folder, Databricks AutoML, and then so on. So if what that's meaning that if I go up into my workspace and you open up the workspace, and then you go to users, and then it had this user, that was my user, and then it'll be underneath of AutoML is what it said. Yeah, Databricks AutoML. And so here's the life expectancy. This is where it's putting all the stuff that goes with that AutoML experiment. While I was talking, it went out and started training the model. And it's the first thing it'll do for us is run what previously was called Pandas reports, and it's now wide data, I think, reports, something like that. What that will look like once it comes up is some analysis of each of the columns. So it will go through and do something very similar to what you see here, but in greater detail, right? It'll break down numbers of nulls and all that other stuff that might even be in here more like this, right? This is basically what it's going to produce. It takes it a little bit to do it, but that's what's coming. And this is something that as a data scientist or an AI individual, you got to know your data first and foremost. That's what we do most of the time, is focus on our data. And while this is still doing its thing, we can check on the status. It updates as it goes. And sometimes you have to kick it to auto refresh, which is kind of what I'm trying to do. Bear with me. Still working on it. So we will have, oh, there it is. There's our notebook. That's the notebook I was telling you about. And this is our exploration notebook, the equivalent of a Pandas reports. Bear with my internet connection. It's a little sluggish. My Starlink connection is great, but getting to my Starlink connection, not so great. So here we are. This is the data exploration notebook. And so the nice thing here is you actually have all the code that they did, right, to get here. So they wrote all this code for us, and you can see here the Pandas profiling, I guess that's the right word, not Pandas reporting, that I was mentioning before, right? So we can go through and take a look at the results of the various variables. Throws up a word tag. Not too sure on country how valuable that is, other than to know Republic is popular in the naming of countries. But anyway, you can see that there are 103 distinct, none are missing. There's a few that seem like they overlap. So 6.2% are distinct. So it means there's only one record for them, which is interesting from a representation of the sampling perspective across countries if you were slicing it that direction. Next, we can see there are 16 years. There's none missing. And they should be a certain percentage distinct because of just how it is. The status, and I didn't mean to click that, I guess I did, which is good. Looks like developing is the only thing in there. Then adult mortality. Now here it gets a bit more interesting, right? So organized, and this should, and we'll take a look and see if adult mortality, trying to see if this is going to align. That doesn't exactly look like ours, but ours is more granular is what's going on. So this is an interesting characteristic of data analysis. And so I'll put this out here so we can kind of just slide it over here in a second. And scroll down to it. So it's the same basic shape, but this granularity, meaning the size of the buckets essentially of the histogram, right, misses this dip. which is really pretty interesting, right? So there's certain dips in the distribution or the histogram that you wouldn't see by combining certain buckets because it kind of averages out those gaps. And you may also miss some spikes by a similar fashion. So by chunking it up, it would match it. But as you can see, you may get more value by going more granular. So just something to keep in mind as a data person. So anyway, we can now kind of scroll through each one of these if we want to. So let's go into more detail on adult mortality. And we can see things like the detailed histogram, common values, and the outliers of ones that are either really small or really big, and how often they occur, and what is the biggest value. This is interesting whenever you're doing your analysis, because a lot of times you may want to cut out your outliers, right? So if you take a look at like the what is it, Airbnb data set for San Francisco, common data set that's utilized in the data circles, there's some outliers out there that are like amazingly large, like thousands of dollars and whatnot for a night stay. But they're probably real, but very infrequently utilized. So maybe there's a mansion that you can rent or something, but or potentially some sort of a event holding hotel size, not a hotel, but something that size that you can rent, or maybe you can rent a hotel. You know, it's a new world. Here we go on to infant deaths, and this was discussed in the details of like per 1,000, I think it was. We'd have to drill back up, but anyway, that's not the point. You want to go through this and look for interesting patterns in your data, and things that you want to take an interest into of why the data might be this way. Measles, BMI. So it looks like there's some patterns of really thin versus a lot of really chunky in certain groups. And then there's a few outliers out here with really large numbers. And then the under 5 deaths, and so on. So again, you would want to look for those extreme values because you may want to get rid of some of these really unusual ones, because clearly it shouldn't go out that far, right? You typically want to prune and remove your true outliers. In this case, we're going to let it go, but just to go through it and make sure you're seeing it. This almost looks like a gap in the data. I don't know that would be explained otherwise. So total expenditure, very odd that there's a gap right there. So we would probably take an interest in that. From a data perspective, and maybe go back and see what's going on with our data set. Diphtheria, some interesting patterns there as well. That might be real versus artificial based upon your data. Gross domestic product of the company or the country, and as you can see, there are some extreme values of the maximum value, which is likely, with the GDP is going to be a Western country most likely, unless that's not in this data set, or it's not going to be a developing country most likely, unless it's a mistagged developing country. Just with that large of a data set or that large of a GDP, you're probably not in a developing country. Who knows? Anyway, thinness from 5 to 9 years, looking for skinny kids, basically. Again, some interesting patterns. You'd like to see a nice histogram, most likely, a nice smooth arc. The gaps probably are real, but based upon some other variable interfering with it. So you could probably include or exclude something and bring it more into line if you needed to, and so on. This time we actually, because it is and I skipped over it on some of the other ones, most likely, because it's a real number. There's apparently some missing values here, which is interesting, as well as there's some zeros. Income composition of resource, we'd want to drill into why that one is, because it's interesting. Schooling, looks pretty good, except for this outlier here. May be real, but it's kind of interesting. And then life expectancy, again, some interesting gaps. So if you look at that, it looks like around the age of 70, a lot of people must die at 70 to make that happen, right? So you want to keep that in mind when you turn 70. My father's up here at this 80 range. Another one that's a little bit of a dip, so that's concerning as well, right? So or this is the other way around, and it's a data problem where people are just putting anybody that's 70 into the 70 bucket, driving down the life expectancy, maybe. I don't know. Interesting problem. So you dig into that a lot more if you're doing this real. While I've been babbling, it's been working and running and learning and training, and we've got some regression that's being done. And so you can take a look at what are the best based upon the value of the R2 score. So that's the worst one, and the best one is up here. And you can see that it's looking like about 0.93 is about as good as we're getting so far. So it shows you the various types of approaches it's using. So it's using an sklearn model, and you can drill into, and we'll go ahead, it gives it a fun name. So this is a column shark, and it's just, those are just random words that are picked to make it not just be a series of numbers that you can remember, and maybe they're familiar and they stick in your head, right? Anyway, so we can actually, if we're interested, open up the notebook. We'll get to that in a minute. So it's showing us the parameters, what went into it, the column selectors, what it's using, and it's the ones that we can kind of expect, and the metrics, and so on. So the values, the metrics that are being calculated that go with this, and you should be able to, bear with me. You can actually see the notebook that goes into this if we really care. The ML model that was used to create it. And this is all the stuff that goes into the process. And so what you can do is take this model with these parameters and so on, and actually register it into the model registry, which would show up over here eventually, right over on the left-hand side under models, and then very rapidly go from using this in a real-world setting, if so be. So keep that all in mind. You do have the overview, the very high-level stuff, the system metrics. There weren't any, I don't think. Some traces if there were, and then over on the right side is the artifacts where we were poking around. And here's the notebooks and the training notebook. This is the notebook that was actually used. And used to could open it, but this will have to open it. Well, we can open it. It's probably under here somewhere. Workspace. It's already down underneath of it. Trials. Anyway, so don't want to go down too much of a rabbit hole. So back up to the experiments, back into the life expectancy that's still running, and you can let it run whenever we configured the AutoML. We set it for how long you want to run, and you can let it run until it either reaches some level or does good enough, or it stops, and it's still training. And we should have a way of stopping it. There's a stop button, but they've changed the UI on me, so I'm having to hunt for it. What's that? It's probably something obvious, like a big red button, but I'm not seeing it. Oh, right there. I knew it's that light red. So if you think it's good enough, you can click on the stop button. Again, you can sort it by the R2 value, R2 score, and We did get a little better, it looks like. This is up, I think we were looking at 9.3 with Mr. Calm Shark down here. So that was the best one, but while we went and poked around and looked at it, a better one came along, which is this guy. And so when it's selected, you can give it a more interesting name rather than a abundant lark, which is fun. It looks like these are kind of like what, descriptive words in front and then nouns or something, or things in the end. Lambs, sharks, snakes, goose, dog. Fun approach. And then a random number to make sure it's really random. And here we can take a look at the data set and so on. We're going to go ahead and wrap things up. Here we're going to click on stop so that we stop spending money. And what that's going to do is terminate the experiment likely at the end of the current one that it was doing. We'll go ahead and see if that changed anything from our abundant lark as far as being good, and no, it didn't. So what this does then is give you a nice solution for potentially solving a problem, not just and giving you the model metrics so you know how well it did on certain things. Graph, system metrics, which are uses, traces, and the artifacts. So you can actually deploy it. So if you wanted to, you can go ahead and register the model, create a new one, call it Life Expectancy. And you can pick to register it either in Unity Catalog or in the model registry. Unity Catalog is a lot of goodness, but in order to do this, you've got to do some other work, right? So you have to go out and do some manual stuff. This will, I'm certain, change over time to be much more approachable. For now, we'll just register it in our workspace. It's nice of it to blank out my name. Go ahead and register it so we can come back to it later on. Each one of those trials would be available to you if you wanted to come back in. And that's being powered by or enabled by MLflow. That's the secret sauce that's making this all work. And so we should now, if we want to go over here and take a look at models, we should see life expectancy. And so you could actually, if I click on it, it'll even be more impressive. Well, it shows you the version, when it was created, who did it. So we only have one version. And then you can actually use the model for inference, right? So that's the nice thing. You would never do it for something like this, but think of this in more interesting terms. And regression's probably not the best value for this, I don't think. Anyway, so with this, I'm going to go ahead and wrap this up. Thank you for watching and listening. I'll talk with you later, and I hope this adds value. If it does, like and subscribe. I will see you around.